Morning. This is a cool event. We saw this facility about 2 weeks ago, and to see what Spark's done is incredible. So thanks, Sparks, for having us out. We're going to talk about some fun stuff today. Pretty excited. So I'm going to start out with a quick joke. I think it's a joke. A semicolon was arrested recently. You may not have heard about this in the news. He was found guilty on all charges and was given 2 consecutive sentences. Okay. There's method to my madness, but we'll talk about jokes and why they're important. So if you've ever been watching the news and you pay attention to Wired or you pay attention to insert geek title here, all you're hearing about is GPUs, right? Raise your hand if you've heard about how GPUs are going to be unlocking the future of AI, right? Just about everybody, right? It's a huge, huge field of interest. But you've all kind of been misled. I hate to say that, but you've been misled. Progress in artificial intelligence is all about our understanding of sentience. It has very little to do with how many GPUs we can put into a box. But that's okay. If you walk away from anything from my talk today, I hope you appreciate 2 things. One, artificial intelligence is going down a fantastic track. It's just not having, it has nothing to do, though, with industry. On the other side, the application of pattern recognition on a grand scale with the utilization of GPUs and other technologies is also making great progress, but those 2 are diverging. You need proof that we're not actually making progress towards true, real AI. Let's take a look at a timeline. Alan Turing created his automated machine back in 1936. And if I were to ask any of you what the 3 most important advances in artificial intelligence have been in the last few years, but some of you would probably say Watson beating Jeopardy, right? I'd argue. This is interactive. Watson beating Jeopardy is a big deal, right? Well, there's a problem, though. As great an accomplishment that was, the algorithms that were developed to beat Jeopardy were created about 1978, right? Significant amount of time before I was born. Co-reference resolution, kind of the underpinning for all the natural language understanding that goes into Watson, is actually a relatively old collection of algorithms, a system of thinking. But it's been dramatically optimized based off of advances we've made on the hardware space. To some degree GPUs, but at the time of Watson, it was actually parallelized processing that really enabled that capability, the ability to beat Watson, or Jeopardy, excuse me. You might also list Microsoft's ability to build extremely deep convolutional neural nets, right? Or to do image detection with a great degree of precision. Well, the only problem with deep image classifiers is that, again, they were developed in 1968. It's been quite a while, in fact, since we've been able to develop a completely new way of matching patterns, right? Trying to replicate the way human beings think about problems. And the third example, probably the most exciting, was when AlphaGo beat the world expert in Go. When would you guess the algorithms that were developed to beat Kijiji were actually developed? Rough ballpark. Late 80s, that's right. 1987 is actually when the Monte Carlo tree technique was formalized. So what's going on? Why are we living in this paradigm where we're getting super excited about these advances in technology that have this affinity to artificial intelligence and yet are not actually derived by anything new, nothing that's pressing? Well, the problem is we've been at a crossroads for a little while, and we've kind of idled there, and we haven't really realized we've been at a crossroads. So on the one hand, we have pattern recognition, capabilities like unsupervised and supervised machine learning, utilizing ensemble classifiers, deep learning networks, deep neural networks. You've got Bayesian techniques that are all getting optimized, and they're working faster and faster and faster on hardware that largely isn't evolving that aggressively. And I would say that's kind of the paved road on the right. We all see it, we all get excited, and NVIDIA is creating the latest Titans, and the latest Teslas, and the latest Voltas, all with these extremely powerful chips. But is that actually advancing our understanding of intelligence? Is that actually pushing us towards such a deep understanding of intelligence that we could create an artificial intelligence, a true generalized AI, or just accelerating these narrow applications of AI? We contend at Valkyrie that the second path, this not well-trodden path, is actually the one that we need to focus energy on more and more as a community. And that's really understanding the structure of knowledge, unwrapping the mysteries of intelligence. We are facing the last real frontier that the human race really doesn't have that great of an understanding on. Right? We understand to a large degree how space works. I'm a former physicist, worked at NASA for quite a while, and I can conclusively say that we understand a significant portion of the mysteries of our universe. It's also true that we've explored a lot of the biological phenomena that are pervasive on our tiny planet. Right? But at the end of the day, the one thing that's still extremely mysterious is how we tell jokes, how we form memories, how emotions play between chemical and semantic interactions. So when I tell you a joke about semicolons, what's really going on in your own brain is a fascinating process. You're actually bridging two different domains that you've been exposed to, you've built models of your entire life. And you're forming a semantic bridge between those two through a process that we don't fully understand. And until we fully grasp exactly what's going on in the background, we have very little chance of creating synthetic AI. But that's okay. It's actually totally fine if that's the case. Because as you'll see, we're actually finding really great applications of pattern recognition that have a big impact on industry. So autonomous vehicles, automated healthcare, even automated legal services, just to name a few of the things that are radically transforming. These capabilities are actually all derived from our ability to adapt pattern recognition really, really quickly. And we're enabled to do this by the work of really great scientists, statisticians, and of course the hardware that supports their work. And I would say that about 95% of the market puts their attention almost exclusively on pattern recognition. When you're reading Wired or any other magazine, they're talking about the advancement of GPUs and how much faster the latest recurrent neural net is at identifying a pattern. Well, that's great. But with that tiny percentage that we're putting towards knowledge engineering, how do you expect to actually advance anything when it comes to understanding the human condition and then transforming that to an automated generalized intelligence? So knowledge engineering is really where I believe, our team believes strongly, we should be putting focus and attention. So at Valkyrie Intelligence is it's a group actually of scientists and strategists that work together. We have physicists, mathematicians, statisticians, biostatisticians, and of course a great complement of strategic thinkers. And we look at industry and we basically figure out ways that AI can work for industry. Right? It's an extremely rewarding job for a scientist. We're a very happy group of individuals working together, solving some really interesting problems in science and technology. But what brings us all together is our fascination with the state of intelligence, understanding really what that means. And we've actually focused almost exclusively our R&D efforts on engineering knowledge systems. So we think about semantic models, we think about graph theory, we think about the application of real hard math and science to solve industrial problems, agnostic to what platforms or particular algorithms are best for or canonically used to solve those problems. So I need a volunteer, somebody who's feeling super bold and brave. That works great. Thanks, Don.
Caught sleeping. I don't like the fact you were trying to figure out how to model jokes. You're putting me out of business.
Yeah. As you'll soon see, you have nothing to worry about.
Okay.
Don, you married?
I am married, yes.
Cool. So if your wife walked past that corridor,
yes,
and there's a little bit of spark cognition fog coming down, would you be able to recognize your wife?
Yes.
Oh yeah, in a heartbeat, right?
She'd probably be yelling at me.
You got a lot of triggers, sure. So I'll try not to trigger you.
Okay.
So she's walking behind there happily, very happy with you
she's happy
at this moment.
Gotcha.
But you could recognize her without an issue.
Mm-hmm.
Now, if I had you and your wife sit down at a table here with a stack of paper and asked you to compute the biggest prime number under 4 million, how long would that take you and your wife to do? You're in the EE background, so you have an advantage.
We would never figure it out.
It would take a long time.
Yeah, we couldn't do that.
Sure. So, so why is it then that I could have a MacBook Pro sit here and in under 40 seconds, it could figure out the largest prime under 4 million, But even if I use the most advanced 152-layer Microsoft deep learning model to use a convolutional neural network and identify your wife, I'd have almost no shot at doing that effectively. What's going on?
Commitment. Vows are vows, my friend. I will recognize her no matter what computing power can beat
That's
me.
right. This is all televised, right? So, great.
Love you, honey.
Great. Thanks, Don. Appreciate it.
That's it?
Yeah, that's it. That's all. That's
that
all
was
I need.
easy.
Thanks, Don.
Thank you.
Amazing, Don. So the point of this whole exercise, the point of me telling a joke, is that Don is able to perform an extremely complicated pattern recognition problem of recognizing his wife at a distance, but he has a really hard time doing the same problem that would take 40 seconds on a MacBook Pro. So why is that? Sure, the Mac has faster cycles, probably in all likelihood, but the key of it, it's the way Don processes models, the way Don stores models of his wife, and that's been trained over experience after experience, and it's bridged across multiple domains. The same reason that some of you, I wish more, but some of you laughed at my joke, right? You're bridging semantic models between two different domains, and you find that funny. So intelligence is built on the superposition of multiple domains that we do just like that. And what we haven't been able to do yet is figure out a way to adequately represent those models in the digital context. I actually personally contend, I don't know if we can. I don't know if there's a way for us to model generalized intelligence effectively using the constraints of the hardware and software that the paradigms that we operate under now. Ones and zeros flipping on and off may not be enough for us to represent a memory or to create a generalized intelligence that gives enough momentum to pass a Turing test, to pass an adept Turing test. So here are some examples of how we manipulate data to create knowledge. If we were to look out over the Spark cognition space, and my role was to find the next best scientist for Valkyrie, right? And I have 3 different sets of data at my disposal. I can look at their driver's licenses and police records, see if they're criminals, and then maybe it would tell me whether or not they speed and the location where they live. You can learn a little bit about a person from that. I can also look at the last thing that they wrote in college, whether that's a paper on neutrinos getting absorbed in Windex, it's a real thing, or if they wrote about Shakespeare. I don't know, but that actually would be really helpful for me to get to know that person a little bit. Or we could analyze a graph of relationships, people who've met each other before, people who've spoken to each other during Spark Cognition's event today. People who bought tickets for Time Machine and started corresponding with other people who were going to Time Machine. All these different data sets actually have information that is valuable to us. And as a human being, you can make a lot of interesting decisions based solely on the combination of these 3 different domains. But computers have a really hard time doing that without a talented data scientist streaming all those sets together. And that last set, the graph, or the network, is arguably the most important part of our current perspective on the future of AI. At Valkyrie, we've invested an exorbitant amount of energy, and both from a research and a development standpoint, in understanding the applications of graph theory. And if we look back at our timeline from 1936 on, there have been some interesting advancements, but it may be that the most important advancement happened in the early 19th century with Euler, who created the foundations for graph theory. Graphs allow us to understand relationships between individuals. Graphs allow us to grow in our understanding of how people and objects and things and services are all interrelated. And we might find that the cognitive abilities that we've cultivated over the course of our whole lives are empowered because of a complex network of relationships. And it's absolutely our quest from an R&D perspective at Valkyrie and my own charter to uncover those mysteries. So we'll continue on working under the paradigm that Hollywood's created for us, that there is a generalized intelligence that's tenable. But until we finally abdicate ourselves from the digital paradigm that we've become so accustomed to, we're going to have a really hard time actually instrumenting it. So at Valkyrie, we have client work, where we're working with some of the biggest financial services institutions, telecommunications, healthcare, energy, government organizations. We're doing really interesting work in the more traditional spaces. So predictive analytics and prescriptive analytics. basically where we're understanding the way systems operate, making predictions about those operations, and even creating adaptive solutions. And that's about as complicated as the industry could possibly handle right now. It's also not valuable yet for us to start implementing intelligent systems. But we continue to develop them anyways, because we're passionate about it, and Valkyrie is committed to thought leadership in the intelligence space. So our R&D sits in the intelligence systems space, because we understand that over time, if you look at the intelligence spectrum, where we have confidence, value, and complexity of systems, over time, intelligence systems will slowly have their complexity decrease and their confidence increase, such that they're actually tenable within the industrial space. I don't want to name specific platforms that are attempting to do this, but there are platforms that work really, really hard to create fully intelligent systems. Systems that can bridge domains, that can appreciate jokes, potentially even write jokes. I don't think we're quite there yet, but I applaud efforts to push in that direction, and I'm solely committed in helping that vision become materialized. So we spend a lot of time, all these success stories from Stitch Fix to Netflix to Insert Flix wherever, all these great companies that are totally disruptive are all implementing more canonical AI, more canonical machine learning, and transforming the world around us. So at its core, two things are happening at the same time, and we should embrace both of them. On the one hand, we have machine learning techniques that are getting implemented by industries across the world. Valkyrie helps a lot of them do it, and that's having a tremendous impact, extremely disruptive impact in different verticals. It's really exciting stuff, but it's not advancing our understanding of intelligence. It's not helping us advance towards a generalized AI. At the same time, we also have research that we're performing, where we're trying to understand the nature of intelligence devoid from the constraints of the digital space that we've come to understand. Right? We work really, really hard to do this, and even though these paths have diverged, Valkyrie is committed, as is Spark, as are a lot of the other people in our space, to still pursue both fields simultaneously. We still want to help industry transform, but we know that pushing the boundary, that's not going to help us understand intelligence. And we want to press the boundaries of what intelligence is and how we understand it, but we know right now that's not going to impact industry. And that's okay. I want to thank you for your time. It's an incredible event. Thanks, Spark Cognition. Thanks to my team for helping with this incredible display we have on the back with the convolutional neural nets on our deep learning server. We are located real close to here, so please let us know if you have any questions. Email me directly, charlie@valkyrie.ai. Come visit our lab. We've got a lot of great scientists and strategists working on the coolest problems in our space. Thanks so much for your time. Have a great afternoon.